Everyone. So today we're going to go over ions, ionic compounds, and to do so we're going to break it up essentially into two questions. The first one that we want to go over is why exactly atoms form ions. Now we've talked about ions already. Ions are just atoms with a positive or negative charge. Well, in order to get that positive or negative charge, atoms will want to lose electrons rather than protons. Losing the proton results in a change of the element. Losing the electrons does not change the element, but effectively changes the charge. So these atoms will go and gain or lose their valence electrons. Again, these valence electrons are those outer ring electrons, the ones on the very outside edge of the atom. The reason why all these atoms will either gain or lose electrons is because they want to have what's called a full octet. 8 valence electrons. That is the key. So the elements that have the 8 valence electrons are right here, the noble gases. Essentially, every single element wants to have what's called a noble gas configuration. They want to have the same number of electrons as a noble gas to try to match up one of the elements in this column. So they're either gain or lose with electrons, whichever one helps them best reach it. If we take a look at some examples here, like for sodium, sodium's electron configuration goes all the way up to 3s1. Sodium is closer to neon for the noble gases. If you take a look here, neon has in the second energy level 8 total valence electrons. Sodium has 1 electron higher than that. So for sodium, it's a matter of losing 1 electron. So if sodium can lose 1 electron, its configuration then matches up with neon. This 3s1 essentially disappears. Now sodium, which has just lost 1 electron, becomes sodium plus 1. The reason why it's a plus sign is because sodium naturally has 11 protons and 11 electrons. But after losing 1 electron, it'll only have 10 electrons. So that means there's going to be a charge of plus 1 left over. Hence why sodium is positive, because there's now 1 more proton than electrons, so there's 1 positive charge not accounted for. Similarly, if we take a look at fluorine, fluorine in the second energy level has got 2 and 5, so 7 valence electrons. Again, comparing this to neon, the closest noble gas to fluorine, it would only need to gain 1 more. So if fluorine can just gain that 1 more electron, this 5 essentially becomes a 6, and now fluorine's got its full octet. The octet again being the 8 valence electrons. So fluorine with 9 protons now gained an additional electron, has 10 electrons. Which means overall there will be 1 electron unaccounted for. That's not going to essentially negate the charge of a proton. So fluorine will take on the -1 charge. These electron configurations are a good indicator of how many electrons are going to be lost or gained, depending on what helps the atom get to the noble gas notation. So we have 2 types that we just saw. Sodium with a positive 1 and fluorine with a negative 1. The positively charged ions are called cations. They're formed by losing electrons. Essentially, you are losing something negative, so overall the atom becomes positive. The charge of a cation is just given by the number of electrons lost. In the previous example, 1 electron was lost, so sodium is going to become a +1. Calcium, who loses 2 electrons, has a +2 charge. When we actually call atoms by their ion name because they've now become ions, the cation does not actually change the name. We'll see it a little different for the anion, but the cation name remains the same, meaning sodium plus is still called sodium, and calcium 2 plus is still called calcium. Now on the other side, the anion, this is the negatively charged ion. This is formed by gaining the electron. We saw the fluorine had to gain 1 more electron to become fluorine -1. And just like the cation, the charge here is indicated by the number of electrons gained. Oxygen, who has to gain 2 electrons, takes on a -2 charge. Now the name of the anion does actually vary a little bit. So with the cation, the name doesn't change, but the anions take on this "ide" ending. So fluorine becomes fluoride. We drop the original suffix, now we add an IDE to the end. Oxygen becomes oxide. Okay, so the cation name does not change, but the anion name changes that ending to an "ide." So why don't you go ahead and practice here. Take a look at these different atoms and try to figure out what the charge of their ions would be and what you would call their respective ions. Okay, and here is the answers to that practice key here. You can see again that all of these cations retain their original element name, but those anions, that ending has all changed to "ide." Okay, so again, all these atoms will gain or lose electrons to mimic a noble gas. They want to have 8 outermost electrons, 8 valence electrons, basically just like what a noble gas has. So now the second question that we want to address here is, how exactly do these atoms gain or lose the electrons, and how do they help each other do so? So if we're going to take a look at sodium and chlorine here, these are what's called dot structures. Structures indicate basically how many valence electrons are present. So sodium's got 1 valence electron, while chlorine's got 7. We just saw that sodium's going to want to lose this electron. Meanwhile, chlorine is going to want to gain 1 electron to get to 8. Well, in order for sodium to lose this electron, it's not just going to release it and be fine. Okay, this electron is still bound to the atom. Although sodium does not want that electron as strongly as some other elements do, it's just not going to give up this electron. Chlorine, though, really needs 1 more electron. The best idea here, if sodium does not want it and chlorine does, this electron essentially gets transferred over to the chlorine. And now, sodium, who has just lost an electron, takes on a +1 charge, while chlorine, who has just gained an electron, takes on a -1 charge. So these elements actually help each other out through the exchange or the give and take of these electrons. That's how elements basically lose and gain their electrons. So the atoms that want to lose the electrons donate them, or essentially give it up, to the elements that want to gain them. Doing so forms the cation and the anion. Cations are positive, anions are negative. Naturally, they're going to be attracted to one another. This attraction between the positive cation and the negative anion is called an ionic bond. An ionic bond is essentially that attraction between the cation and anion. This newly resulted compound from this bond is called an ionic compound. So by giving up the valence electron and gaining 1, you form these ions. These ions, by their electrostatic attraction, get pulled towards each other, creating what's called an ionic bond, and that results in an ionic compound being formed. Now, ionic compounds, like I just mentioned, are formed through the attraction of the cation and anion charge. Metals typically form cations and nonmetals form anions. So ionic compound can also be viewed as having a metal and nonmetal component. Now, even though these compounds are made of ions, the compounds overall are neutral. The positive and negative charge in the compound actually balance each other out, so the overall charge of the compound is 0. The formula of your ionic compound indicates how many atoms of each are present. And the ionic compound is just named by the ions in it. So if we took a look here with the sodium and chloride example, the positive and negative attraction pulls them together. You can see here that the +1, -1 cancel each other out, so overall a charge of 0. There's subscripts of 1 over here indicating it just takes 1 of each of these atoms to create this here. And sodium ion and the chloride ion come together to make sodium chloride. The name is really as simple as just the name of the ions that make it up. So why don't you go ahead and practice here. You're going to want to form the ions for each of these elements. and then figure out what the formula will be and what the name of the compounds will be. Okay, and then here is that answer key. So you can see here that all of these have got a +1, -1 charge. They take on the cation, anion name here. They should all end in some kind of "ide." This last one may be a little different. You can see here that we have a CaCl2. I'll get into why the two here if you haven't already figured that out. So talking about the ionic compound formula, we have to keep in mind that the ionic compound has to be neutrally charged, meaning that the positive and negative charges must be balanced. So if we take a look at that calcium and chloride example, calcium's got 2 valence electrons here. Chlorine has 7, it only needs to gain 1. So this 1 electron will go ahead get donated to the chlorine. The problem is there is still 1 electron left. So calcium has got to give up both. It cannot just give up 1 valence electron. It's going to be in it for the long haul, so it means it has to give up all of its valence electrons. The best solution here, because we're talking about calcium and chlorine, is if a second chlorine is involved. So these chlorines, who have 7 valence electrons, each need to gain 1. If one chlorine can only take 1 away, in order to remove that second valence electron, we would need a second chlorine. Thus, you end up getting the calcium with a +2 charge, because it's now given up 2 electrons, and now you have 2 chlorines, each with their -1 charge, because now you have 2 chlorines that have gained 1 electron. One chlorine cannot gain both. One chlorine can only gain 1, hence the need for a second one. You can see now the +2 is canceled out by the 2 -1 charges. And now in our formula we have calcium, 1 of those, and chlorine, but now we have 2 of those, hence why it's CaCl2. Okay, so there's a very simple way to try to figure out how exactly to write the formula from the charges. One, you can just crunch the numbers, right? So here we have calcium with a +2, chlorine with a -1. Well, we know we want to get that to 0. If we have a +2 here, for chlorine, 1 minus 1 is not going to cut it. We would need 2 of them here to get the -2, and then some of this would give me an overall charge of 0. So you could just do a little bit of math there. But a much easier method is called the crisscross method. Essentially, this helps find you, by switching up the charges, it creates these subscripts, essentially finding some kind of form of like a lowest common denominator thing. It's very, very simple. Just by taking the charge of the cation and the anion and crisscrossing them, you essentially get your formula here. What I mean by that, the 2 from the +2 calcium goes down to the chlorine. The 1 from the chlorine goes down to the calcium. So that 1 from the chloride anion is now part of calcium, so Ca1. The 2 from the calcium now goes down to the chlorine, you have Cl2. That's the crisscross method. It is as simple as just dragging the charges down to the other atom and making them a subscript rather than an exponent. If we take a look at the same thing here, calcium's +2 will go down. We don't bring the actual positive or negative, we only really bring the number here. So then you have Ca2O2. Okay. But one thing to keep in mind doing this method, we have to reduce these subscripts as much as possible. Okay, so that is one very, very important thing to remember here. The formula subscripts must be reduced. So the Ca2O2, they're each reducible by a factor of 2, so we basically get CaO, and this is because the +2 of the calcium only needs 1 of those oxygen -2s to give you an overall charge of 0. So it's basically just a 1-to-1 ratio. So the crisscross method makes it very, very simple in order for you to kind of just figure out what the formula is based on the charges of the previous atom. Okay, so why don't you go ahead and practice here with all these different combinations. Again, write the ions out, derive the formula, and produce a name for them. And here is that answer key. Okay, so these ions will naturally bind together, forming what's called an ionic bond. The ionic bond is just that attraction between the positive and negative cation and anion, and it's just the attraction between them.